Dear children, today we are going to discuss about an important concept, the converse of basic proportional theorem in class 10th under triangles chapter. We have discussed about basic proportional theorem. Now we are going to discuss about its converse. What is this converse of basic proportional theorem? We'll see. Converse of basic proportional theorem. If a straight line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. This is converse of basic proportional theorem. What basic proportional theorem says? In a triangle, if you draw a line parallel to one side, that line divides other two sides in the same ratio. And here converse is when you draw a line and that line is dividing two sides in the same ratio, then that line is parallel to third side. That is converse of basic proportional theorem. Here ABC is a triangle. ABC is a triangle. In triangle ABC, DE is a line. DE is a line. That line divides this AB side and AC side in such a way that AD by DB is equal to AE by EC. That means those two ratios are equal. That means that line divides two sides in the same ratio. In triangle ABC, line DE intersect AB and AC such that AD by DB is AE by EC. It divides in the same ratio. That is given. Now we have to prove that that line DE is parallel to BC. We have to prove that DE is parallel to BC. We prove this theorem in a contradictory way by using contradictory method. What is this contradictory method? Here actually we have to prove that this DE is parallel to BC. We suppose or we assume that this DE is not parallel to BC. We assume that this DE is not parallel to BC. If DE is not parallel to BC means there must be a line which is parallel to BC. So we take that line as DE dash. This DE dash is parallel to BC. Observe clearly. Here we assume that this DE is not parallel to BC. That means there is a line which is parallel to BC. That line is DE dash is parallel to BC. Now, let us prove. Now in triangle ABC, this DE dash is parallel to BC. So by basic proportional theorem, what you will get? AD by DB is equal to AE dash by E dash C. By basic proportional theorem. Let it be 1. Next, but we have given that. What is given? AD by DB is equal to AE by EC. It is given. Now we proved AD by DB is equal to AE dash by E dash C. If you observe these two equations, here LHS AD by DB, here also LHS AD by DB, these two LHS are equal. When these two LHS are equal, then this RHS also equal. That means AE by EC is equal to AE dash by E dash C. So AE by EC is equal to AE dash by E dash C. Let us add 1 on both sides. We know that if equals are added to the equals, the wholes are equal. So here AE by EC plus 1 is equal to AE dash by E dash C plus 1. If you simplify, we will get here AE by EC plus 1 that can be written as AE plus EC by EC. This is equal to AE dash plus E dash C by E dash C. But what is this AE plus EC? AE plus EC. AE plus EC is nothing but AC. And AE dash plus E dash C. AE dash plus E dash C is nothing but AC. So here this AC by EC is equal to AC by E dash C. In these two, numerators are equal. Here these two fractions or ratios are equal, and here numerators are equal. Automatically denominators also equal. So EC is equal to E dash C. If you observe the diagram, EC means this part. This is EC, and E dash C is this one. From here to here, this is E dash C. These two are equal. Is it possible? It is possible. When it is possible? When this E and E dash, if these two coincides, if these 2 points coincides, then this EC and E dash C will be equal. When these 2 points coincides, then this DE will be parallel to BC. DE will be parallel to BC. That means in a triangle, if a line divides any two sides in the same ratio, that line is parallel to the third side. It is known as converse of basic proportionality theorem. By using this theorem, we do a problem. Here, in the following figure, the values are given. Here PQR is a triangle, and M and N are 2 points. MN is a line. This MN divides this A, PQ and PR in some ratio. Here the values are given. PM value is 15. PM value is 15 centimeters. And PQ value is 25 centimeters. And NR value is 8 centimeters. And PR value is 20 centimeters. Let us find the ratio PM by MQ. PM is 15, it is given, and PQ is 25. Whatever this MQ, this is 10. And here PR is 20 centimeters, NR is 8 centimeters. What about PN? This PN is 12 centimeters. Let us find the ratio PM by PQ. This is 3 by 5. And PN by PR. PN by PR. PN by PR is 12 by 20. This is equal to 3 by 5. Therefore, PM by PQ is equal to PN by PR. So these two are equal. Therefore, this MN is parallel to QR. By converse of basic proportional theorem, when this MN is dividing two sides in the same ratio, that means this MN is parallel to QR. We take one more example. Very simple. Here in the given figure, this PQR is a triangle. A, B, C are points, and O is interior point. A is a point on OP, and B is point on OQ, and C is point on OR, such that this AB is parallel to QR. This AB is parallel to QR, and AC is parallel to this AC is parallel to PR. Then we have to show that this BC is parallel to QR. For that, if you consider triangle POQ, if you consider this triangle POQ, in this triangle POQ, AB is parallel to PQ. That means one line is parallel to one side. So by basic proportional theorem, we can write that OA by AP is equal to OB by BQ. OA by AP is equal to OB by BQ. Next, in triangle POR, this AC is parallel to PR. Again by basic proportional theorem, we can write that OA by AP is equal to OC by CR. OA by AP is equal to OC by CR. Now if in these two equations, if you observe the LHS, both LHS are equal, therefore RHS are also equal. That means OB by BQ is equal to OC by CR. What is this OB by BQ and OC by CR? In triangle OQR, this BC is dividing OQ and OR in this ratio. OB by OQ is equal to OC by CR. That means that BC divides two sides in the same ratio. Therefore, by converse of basic proportional theorem, this BC is parallel to QR. BC is parallel to QR. So like this we can use this basic proportional, converse of basic proportional theorem in solving the problems. Thank you.